Good morning, everyone. Today I want to talk about kind of the next step in difference of squares. I want to make it just a little bit more complicated um, and add kind of another factoring tool just in general. And what that is the ability to pull something out of an entire equation. Now, yesterday we were looking at things that looked like x squared minus, what am I going to want to use here? Let's just use 16 because it'll be fine. X squared minus 16. And we would factor that into x minus 4, x plus 4, because it's the difference of squares. Yay. Okay? Today, I want to make it just a little bit more difficult by putting like a 5x squared minus 80. Now, yesterday we could deal with this if this were also a perfect square, like 4x squared minus 16 wouldn't have been a problem. But this 5 doesn't have a perfect square. It's an irrational number that goes on. It's gross. So we don't want to deal with that. So we can't use difference of squares here. It ain't going to work. But what we can do is take something out. We can factor a piece out of the entire thing. Now, if you remember, I'm going to do just a little bit of a side problem down here before I get back to that. We used to, when we would distribute, do things like there would be a 3 out front, and we would have like a 2x plus 4 inside. Okay, and we'd give you problems like this, and you say, oh, okay, we take the 3, we multiply it by the 2x, 3 times 2 is 6, there's just the 1x, we keep the plus, 3 times 4 is 12, and we sing a little song while we do it. And we get 6x plus 12, and then we have a little party and move on to the next problem. Okay, what we want to do today, and the tool that we're going to work on, is that 3, we're going to yank that back out. Okay? Which I realize is actually a terrible example because I could have pulled a 2 up too. So we're going to come back up here now, and we're going to practice pulling stuff out. You can always factor pieces out if it's divisible by both of these. Now, part of the problem with factoring is we use factoring for a lot of different problems, and it ends up meaning a lot of different things. So when we talk about factoring, what we're really talking about is taking something and breaking it down into smaller pieces. So yes, what we did 2 days ago was factoring. What we did yesterday was a slightly different kind of factoring. Today we're dealing with a slightly different kind of factoring. All of it to try and break it down. And the reason we want to break it down is it makes the problems more bearable. It gives us something that we can handle. If this were an equation, if we set this equal to 0, we wouldn't be able to solve it because we've got that funky x squared in there. We've got to break it down first. Okay, we have to simplify things. This is a useful thing if we were doing some graphing, but dealing with equations, paper, pencil, even in calculators, it's not something that we want to deal with. So we got to break it down. Okay, so if we look at this 5x squared and we look at this 80, we can see that 5 is the only factor I've got here. 80 is also divisible by 5. So I can pull out a 5 because both of these numbers are divisible by 5. And it's the largest number that is divisible by both. One thing that you can do to help you out a little bit if you want to is make a factor tree. 5 is easy. It's a pretty small number. 80 is going to take us a little bit longer, but that's fine. I always like to start with 2. I'm going to set my 2 over here just so I can come back into the middle. Okay. 5 is my biggest factor. I've got a factor of 5 over here, and there's nothing else that they have in common, so I can pull 5 out. So we are undistributing. Kind of like 2 days ago we were unfoiling, now we're undistributing. That's a really dramatic gesture, and I just like doing it. Okay, so we're going to pull out a 5. That's an ugly 5. Okay, so we pulled out our 5. But that means that the 5 isn't in there anymore. So we've kind of divided both sides by 5 here. 5x squared divided by 5, those will cancel. I'll be left with just an x squared. 80 divided by 5 is 16. And now when we see what's on the inside, that looks like something we can play with. That's something that we could do yesterday. So we're going to break that up now. X squared minus 16 is x minus 4, x plus 4, and don't forget the 5 out front. So there is your answer. Now, another piece of this. This will also work if I have another equation that looks like 2x squared plus 12x plus 10. Okay? Now, we haven't started to deal with coefficients out in front of the x squared yet. That's fine. We'll get there. Probably tomorrow. Okay? But with this problem, we don't actually have to do that. We're just going to factor out a 2, because if you look at this number, 2 is divisible by 2. Everything's divisible by itself. 12 is divisible by 2, and 10 is divisible by 2. So I'm just going to pull a 2 out. And that'll leave me with x squared plus 6x plus 5. And now this is just the problem we were doing 2 days ago. Factors of 5, 1 and 5. So I know that I'm going to be dealing with a 1 and a 5. It's an x squared, so there'll be an x and an x plus plus, and everything's got to be positive. Don't forget the 2 out front. Today is a really good example of most of the math that we do in school. The biggest trick in math is take something you don't know how to do, make it look like something you do know how to do. So we're going to take something we don't know how to do, turn it into something we do know how to do, and then handle it. So that's the plan today. Let me give you one more problem, maybe one more example. Let's see how I feel when I write. Let me see what I start writing, and then I'll decide if I want you to do it on your own. Because yesterday I forgot to give you a practice problem, and I'm sorry. And I know that you don't actually care, and you're probably not actually that upset about it, but I do really want you to get good at this stuff, and I hindered that ability. So, sorry. I mean, not as much as COVID has, but I'm still hindering. Anyway. Oh, one more example. Yep, I do want to give one more example. Let's say that we have a 4x cubed minus 100. X. Okay? Again, stuff here we don't know how to deal with, because we already talked about we can get that 4 out, and that's fine. And even if we didn't want to get the 4 out, 4 is a perfect square and 100 is a perfect square. We've got a couple tools to deal with this, but that x cubed, well, that's a son of a gun. Okay? Because x cubed ain't x squared, and cubed things don't have perfect squares. But that 100, that's also got an x on there, which means not only can I take a 4 out, because there's a 4 in both of these, I can also pull out an x. So what's left over? Well, I pulled out a 4x, so the 4's will cancel, and an x cubed divided by 1x will give me x squared, minus 100 divided by 4 is 25. X divided by x will just cancel out. And in both multiplication and division, that's how I like to treat things. Deal with the constant and the constant, and then your variable and your variable. Okay? Don't try and crisscross them. Okay? So you've got 4x, and then in parentheses, x squared minus 25. Well, we know how to deal with that. That's just difference of squares. Square root of x is x. Square root of 25 is 5. Plus minus, don't forget the 4x up front. Okay? Take something you don't know how to do, make it look like something you do. Practice problem coming. Take a moment, work on 28x cubed minus 100x. Go. Shazam. Okay. I strongly suspect as the try goes longer, the sound effects are going to get weirder as I slowly become cramped and a little bit cabin fevery. So, Shazam. Word of the day. All right. 28x cubed minus 100x. We've got to factor something out of there. Yeah, I did it right. First of all, we know we've got to deal with the x. As soon as you see an x cubed minus with an x, you know you got to get the x out of it. Okay, that's just, and I hate to say this, but it's on a homework, on tests, get rid of the x. Like that's just something you should notice. Okay. 28 minus 100. Excuse me. The biggest number that those two are divisible by is 4. So just like the last problem, factoring out 4x. What we will be left with, 28 divided by 4 is 7. Oh, I made this problem wrong. I didn't mean for it to be 28. Crap. 4 times 9 is 36. There we go. So this is going to be the problem. Sorry about that edit there. I gave you a problem that didn't work. I just did bad brain math. Okay, so what we're going to do is this 36x cubed minus 100x and go. And we're back. So what we need to do here is look at both of these and factor something out. You should automatically notice the x and the x cubed and just take out an x. On tests, on homework today, if you see this going on, just get up, bring out the x. As soon as you see an x cubed, there's probably going to be an x over here because I can't make it work without that. So just assume that's happening. Looking at this 36 and this 100, the biggest number that both of those will be divisible is by 4. So I'm going to be dividing both of these by 4x. So 36 divided, sorry, I should put the 4 out there. 36 divided by 4 is going to give me a 9x squared minus 100x divided by 4 is going to give me a 25. Difference of squares is kind of an ugly one, but this is something we handled yesterday. Square root of 9 is 3. Square root of x squared is x. We'll have a 3x on both sides. 25 is 5. Minus plus plus minus, doesn't matter. 4x out front. Do me a favor on the homework. Technically, the 4x could go here or between the parentheses or at the end. Don't, because that means that I have to put like 12 different possibilities into the quiz so that they would all be marked correct, and I'm not going to do that. I will make sure that minus plus or plus minus are both covered. Keep whatever you factor out in front, please. Sorry, I'm just not going to write 12 different possible answers for each one. If you got this answer, awesome, you're good to go. Otherwise, talk to me, jump into Google Hangout, and that's what we've got for today.